Hello everyone. I hope you are doing good. In this video, I will explain equation of plane passing through 2 points and parallel to a vector, or you can say parallel to a line, or you can say perpendicular to a plane. Okay. So here is what is the vector equation of plane? Vector equation of plane passing through 2 points A of A bar and B of B bar, and parallel to the vector C bar vector, right, is in vector form that R bar is equal to 1 minus T into A bar plus TB bar plus SC bar for some scalars T and S, right? T comma S are some scalars. I will prove it. Or you can say that box of R bar minus A bar, B bar minus A bar, C bar equal to 0. Well, how did we get this? It is just a matter of application of coplanar vectors. Coplanar vectors. Three vectors are coplanar if their box is equal to 0, or one vector can be expressed as linear combination of other two vectors. Well, here you see that A plane passes through A of A bar and B of B bar. Well, so here I have taken 2 points on a plane and parallel to C bar vector. Now you take that any point on the plane is P of R bar. Plane passes through A of A bar, B of B bar, and parallel to C bar vector. Well, so now join A and P. We got one vector. Join A and B. We got another vector, right? Now parallel to C bar vector, you take a vector on this plane. This is C bar vector. All right, this is C bar vector. It is not necessary that vector C bar should lie on the plane. It can be parallel also. So this is C bar vector. Now observe that AP bar vector, AB bar vector, and C bar vector, they are coplanar. One AP bar vector, AB bar vector, and C bar vector. There is no need to maintain any order. You take any order. Right. Well, so here AP bar, AB bar, and C bar are coplanar vectors. Then what do we write? We write that one vector can be expressed as a linear combination of the other vectors. So some T into AB bar vector plus S into C bar vector, isn't it? This is most important. So now from this onwards, it is so simple to get that expression that AP bar vector is nothing but OP bar vector, that is R bar, minus OA bar vector, that is A bar, equal to T into AB bar vector, nothing but OB bar minus OA bar vector plus SC bar. We just need to find that R bar that's is equal to that 1 minus T into A bar after grouping the terms A bar, B bar plus TB bar plus SC bar. We got it. Here T comma S are some scalars. This is the vector form. Now as AP bar, AB bar, C bar are coplanar, okay, so we can have that box is equal to 0. Box of AP bar, AB bar, and C bar equal to 0. Right. Well, this is nothing but box of R bar minus A bar and B bar minus A bar and C bar equal to 0. Further, you can write several expressions which can be deducted from this. If you want, you can write that R bar minus A bar dot B bar minus A bar cross C bar equal to 0. This is nothing but R bar minus A bar dot B cross C plus I can write C cross A. Now you can put in box form. It is so simple to put in the box form. Now this implies you take the dot product with R bar, then you will get box of RBC. Well, plus box of RCA minus box of ABC. That's equal to box of ABC. This is also equation of plane in different formats. Right, so vector form is over. The most basic point is that the box of R bar minus A bar and B bar minus A bar and C bar equal to 0. So again, it's a determinant equal to 0. Now, how to find out equation of plane when we specify the points in Cartesian system? This is the most important one, right? Okay. So what is the equation of plane? A x1 y1 z1, B x2 y2 z2. Nothing but this is A bar vector and this is B bar vector passing through 2 points. And parallel to the vector, this is C bar vector. Parallel to the vector AI plus BJ plus CK. There are several ways to express the same context. What are those all? I'll explain. See, we need to find out a plane containing 2 points and parallel to a vector. So they will give in different ways. Like what is that? Here, those points will remain same. They will remain same. Parallel to AI plus BJ plus CK. They will give vector directly, or they can say parallel to a line having DRS ABC. Well, a line is parallel to the plane. A line is parallel to the plane means a line is parallel to the directional vector AI plus BJ plus CK. Hence, the plane is also parallel to that vector AI plus BJ plus CK. Second one is over. Or they can say perpendicular to the plane. They can say perpendicular, passing through 2 points, and perpendicular to the plane AX plus BY plus CZ plus D equal to 0. Sir, how this is possible that it is perpendicular to the plane AI plus B? See here, look at this diagram. I want to find out equation of plane that is pi passing through 2 points AB and perpendicular to the plane. Here you see normal of this perpendicular plane is AI plus BJ plus CK. How is this normal to the required plane? This normal is parallel to the required plane. So ultimately we got the same position, right? So therefore, perpendicular to the plane AX plus BY plus CZ plus D equal 0 is nothing but plane is parallel to AI plus BJ plus CK. Or this is also important. Containing the line and passing through x2, y2, z2. Well, okay. Containing the line. So a plane contains the line is nothing but a plane is parallel to that line. A plane contains the line is nothing but this line is parallel to the plane. So here see that line passes through x1, y1, z1. Hence the plane also passes through x1, y1, z1. And also it passes through x2, y2, z2. This is the point B. And you see that line is parallel to AI plus BJ plus CK. These are the DRS of the line, right? So line is parallel to that C bar vector. This, sorry, C bar vector. This is C bar vector, right? So here C bar is equal to AI plus BJ plus CK. These are all represent same. These all represent the same concept. Or you can say that containing two lines, that x minus x1 by a equal to y minus y1 by b equal to z minus z1 by c. So there are two lines on the plane. First line passes through x1, y1, z1. Second line passes through x2, y2, z2. Anyway, again, we got 2 points on the plane and parallel to C bar vector. This is the C bar vector. For all these, right? For all these, modulus of x minus x1, sorry, not modulus, sorry, determinant of x minus x1, y minus y1, z minus z1. So the first one is nothing but r bar minus a bar. Second row is nothing but b bar minus a bar. Third row is nothing but c bar vector. So this is nothing but r bar minus a bar. Second row is nothing but b bar minus a bar. And third row is nothing but C bar vector. I have just used that box of R bar minus A bar, B bar minus A bar, C bar vector, one in all. See, I have explained how many different ways to find the plane, which has only one formula, that is passing through 2 points parallel to one vector. Our aim is to find out equation of plane containing 2 points and parallel to one vector. However you give that parallel vector, that is fine. Whether it is parallel to the line or whether it is perpendicular to a plane, it's okay. Or whether they give vector directly, then also it's okay. So we need 2 points parallel to one vector. Or line having DRS ABC parallel to the line. Or perpendicular to the plane AX plus BY plus CZ plus D equals 0, nothing but it's normal parallel to the required plane. Or directly they can say that containing the line x minus x1 by a equal to y minus y1 by b equal to z minus z1 by c, and passing through another point containing the line. For all these, the only one and one formula, that box of r bar minus a bar, b bar minus a bar, c bar is equal to 0. Determinant of x minus x1, y minus y1, z minus z1. You will get this equation of plane in 1 minute if you really understand the concept. Well, I'm going to explain a few questions. If the point 2 alpha beta lies on a plane which passes through 3, 4, 2 and 7, 0, 6 and perpendicular to the plane okay, it is exactly same as of which one? This one, passing through 2 points and perpendicular to a plane. So what is the formula? This is the formula. All right, so therefore here that I'll keep that formula there only. This is the first point A, this is the second point B, right? So now the plane equation is given by, use the determinant directly, that x minus 3, y minus 4, z minus 2, isn't it? Now x2 minus x1, subtract a coordinates from b coordinates, 4 minus 4 and 4. Right. What are the DRS of normal of the plane? DRS of normal of the plane are 2 minus 5 and 0. It is that required plane is parallel to the vector 2i minus 5j plus k. So this is equal to 0. Good. We'll do it now. X minus 3 into, it is 20. Minus of y minus 4 into, it is 0 minus 8. Plus z minus 2 into minus 20 plus 8 minus 12 equal to 0. You can cancel by 4, right? 5 into 5x, I will multiply minus 15. We are dividing by 4, okay. This minus of minus plus 2y minus 8 dividing by 4 minus 3z plus 6 equal to 0. This implies 5x minus 2y minus 3z, okay, and minus 23 plus 6, that is nothing but minus 17 equal to 0. We just need to verify whether this is correct or not. For that, you substitute the point, any one of the points. Substitute 706. If you substitute 706 here, you will get here 35. And this is minus 18, minus 17, nothing but minus 35. Hence, the plane is correct. Now, 2 alpha beta lies on the plane. 2 alpha beta lies on the plane. 2 alpha beta lies on it. Lies on it. So you just substitute this point in the plane. X is 2, so 5 into 2 minus 2 alpha minus 3 beta minus 17 equal to 0. All right. So this we got that. Let me see once that this is plus 2y and minus. Yes, here this is plus 2y. Sorry. Plus 2 alpha. So this implies you will get that 2 alpha minus 3 beta is equal to, right? It is 10 minus 17, nothing but minus 7. Sending that side, you will get 7. We got it. So once the key idea strikes out, then we can find the plane right away. Passing through 2 points, parallel to a vector or parallel to a line or perpendicular to a plane. All are same, or containing the line. Here is one more question. I will explain questions of different models. Let P be the plane, right? Passing through the line and the point, right? Passing through the line is nothing but plane contains the line. Plane contains the line. Okay, so straight away, what is the plane equation? Plane passes through 1, 2, minus 5. Plane passes through 1, 2, minus 5. So plane containing the line, nothing but passes through 1, 2, minus 5. So determinant of x minus 1, y minus 2, z plus 5. And also passes through the point 2, 4, minus 3, x2 minus x1, y2 minus y1, z2 minus z1. And parallel to the vector I cap minus 3j cap plus 7k cap. So this implies that x minus 1 into 14 plus 6, that is 20, minus y minus 2 into 7 minus 2, 5, plus z plus 5 into z plus 5 into minus 3 minus 2 minus 5 equal to 0. All right, so this implies you can cancel by 5. You will get that 4x minus 4 minus y plus 2 minus z minus 5 equal to 0 implies the plane equation is now we obtain 4x minus y minus z minus 7 equal to 0. Let us verify whether this plane is correct or not. Substitute 2, 4 minus 3. You will get 8. 8 minus 4, 4. 4 plus 3, 7. Yes, plane is correct. Now question is not yet over. Now every question is two-tied question. We have to find out that foot of perpendicular. Foot of perpendicular, not foot of perpendicular. I am very sorry that they are asking image of the point. In the plane is alpha, beta, gamma. So let us write image formula. That image is given by that alpha minus of minus plus 1. Okay. Alpha minus x1 by x coefficient of the plane is 4. Y minus 3 by y coefficient of plane is minus 1. Z minus 4 by z coefficient is minus 1. Minus 2 times of substitute this point from which you want to find out image in the plane, that is 4 into minus 1 minus 3 minus 4 minus 7 whole by a square plus b square plus c square is nothing but 18. All right, this is a minus 4. Okay, so this is minus 18. 18, 18 cancel. You will get 2. So therefore, on doing the cross multiplication with each ratio, you will get that alpha is equal to 7, equating these two. Right, this is beta. Sorry, this is beta and gamma. Beta minus 3 and gamma minus 4. Beta equal to you will get 1 and gamma equal to you will get 2. So what is alpha plus beta plus gamma? That is equal to 10. We'll move to next question. Every question will be up like this only. They will ask to find out the equation of plane passing through 2 points and parallel to a vector. If the equation of plane passing through the mirror image of this point with respect to the line. Again, it is a two-tier question. Equation of plane passing through a mirror image of this point and containing the line. Right. So line passes through mirror image of this point and also passes through 2, 1, minus 1. And parallel to the vector 3i minus 2j plus k. Well, okay. So first what I will do is I'll rewrite this equation of line. It is not in proper way. Okay. So I'll rewrite this equation as x minus 2 by 3 equal to y minus 1 by minus 2. Be careful. Sometimes they will give like this, z plus 1 by 1. Z plus 1 by 1. Now, first we need to find out what is the image of the point in the line. What is the image of the point in the line? Well, so here is the procedure. This is the line L. And they have given the point. Assume this is the point P. Point P is 2, 3, 1. I will find out first of all what is foot of perpendicular Q. So this is the line L. What is the any point on line L? What is the any point on line L? That you will get 2t minus 1. Assume this is equal to t. And t plus 3 minus t minus 2. Okay, this is the line L. Now PQ is perpendicular to L. So implies what are the DRS of PQ? That 2t minus 3 into 2 plus that is t into 1 plus minus t minus 3 into minus 1 equal to 0. So this we get that 4t minus 6 plus t plus t plus 3 equal to 0. So therefore, t we get that is equal to 3 by 2. Hence, we got the point q equal to 3 minus 1, 2. And it is 3 by 2 plus 3 is nothing but 9 by 2. And minus 3 by 2 minus 2 is nothing but minus 9 by 2. Minus 7 by 2. So this is the foot of perpendicular. This is the foot of perpendicular. So what is the image? R is the image of the point, right? So image of the point P is equal to 2 times of Q minus P. Nothing but 4, 9 minus 7 minus point P, nothing but 2, 3, 1. So this is equal to 2, you will get 6 and minus 8. So this is the other point on the plane. This is the other point on the plane. Now, what is the equation of plane containing this line and also passes through this point? We'll write the plane equation now. We use the determinant that plane equation is given by now determinant of, okay. Here you see that plane contains this line that I'll write as it is that x minus 2, y minus 1. You take any point, z plus 1. All right. And x2 minus x1, you substitute this point here 0, 6 minus 1, 5, and minus 8 plus 1, that is minus 7. And what are the DRs of this line? 3 minus 2, 1. Put here 3 minus 2, 1 equal to 0. Now calculations is left. Only simplification part is left, that x minus 2 into, isn't it? This is 5 minus 14, that is minus 7. Sorry, 5 minus 14, minus 9. Minus of y minus 1 into, it is 21 plus z plus 1 into, z plus 1 into, it is minus 15 equal to 0. All right, you can cancel by, in fact, minus 3. So you will get that 3x minus 6 plus 7y minus 7 plus 5z plus 5 equal to 0. All right. Okay. So 3x plus 7y plus 5z is equal to, this is 13. That side we got 8. That side we got 8. So let me check whether this plane is correct or not. I'll just substitute 2, 6 minus 8. It is 6 and it is 42, right? 48 minus 48 equal to 8, correct. But they have given that alpha x plus beta y plus gamma z equal to 24, right? So on RHS, we have to adjust that 24. For that, you need to multiply by 3. So this implies 9x plus 21y plus 15z is equal to 24. Right. So what is alpha plus beta plus gamma? Oh, I just got a wrong answer. What is alpha plus beta plus gamma is equal to? I don't have any answer. I'll check it out. I found my mistake here that 4t plus t plus t 60 equal to 3, t equal to 1 by 2. Okay, this mistake I did. Now the point q is equal to, that is 1 minus 1, 0. Change the coordinates of q. 1 minus 1, 0. Substitute t equal to half here. You will get 7 by 2. And substitute t equal to half here. You will get minus 5 by 2. Well, the same we will write here that these coordinates 2q is nothing but 2q is nothing but multiply by 2, 0, 7 and minus 5. And subtract that P point, you will get minus 2, 4 and minus 6. This is the point. So accordingly, these will be changes. Now I'll remove this. If one mistake is done, instead of plus or minus, entire solution will gone. Now here you see this is minus 2 minus 2, that is minus 4. Here we get that minus 4. 4 minus 1, 3. Substitute this point. This is minus 5. Implies that x minus 2 into this is 3 plus 5, that is 13. Okay. Oh, 1 minute. 3 minus 10, that is minus 7. Minus of y minus 1 into, it is minus 4 plus 15. Minus 4 plus 15 is nothing but 11. Plus z plus 1 into, it is 8 minus 9, that is minus 1, equal to 0. So this implies you will get that minus 7x plus 14 minus 11y plus 11 and minus z minus 1 equal to 0. This implies 7x plus 11y plus z equal to, this is 14 and plus 11, 25 minus 1, 24 left here. So we got it. So this is alpha, this is beta, and gamma is 1. Right. Now one more last question, that a plane passing through 2 points and making an angle pi by 4 with y minus z plus 5 equal to 0. Well, so this I will do now. So plane passes through 2 points and assume that parallel to the vector ai plus bj plus ck. Right. We don't have any parallel vector. Assume that plane passes through 2 points and parallel to, okay, ai plus bj plus ck. We need to find out ABC values. This is the plane. X minus 0 plus y plus 1, z minus 0, 0 minus 0, and 0 minus of minus plus 1, etc. I wrote, and I have expanded that. We got the plane, that plane pi c minus b into x plus ay minus az plus a equal to 0. Now this plane makes an angle 45 degrees with another plane pi 1. Assume this is pi 1. Angle between pi comma pi 1 is given as pi by 4. Therefore, angle between the planes is nothing but angle between their normals. Angle between their normals. So, here the normal vector of plane pi is c minus b into y plus a j minus a k. And plane pi 2, normal of plane pi 2, there is no I component, simply j minus k. C minus b into 0 plus a into 1 minus a into minus 1 whole by under root c minus b whole square plus a square nothing but 2a square into root 2. Root 2 cancel. This is cos pi by 4. Now on squaring both sides, you will get that c minus b whole square plus 2a square. On RHS, you will get that 4a square. Implies c minus b is equal to either root 2a or minus root 2a. Substitute here. Substitute in the plane pi. Now, what is the plane pi? Plane pi is now, if you substitute that root 2a, okay, then here substitute root 2 plus or minus root 2a into x plus ay minus az plus a equal to 0. There are two planes. Now you can cancel a. So plus or minus root 2x plus y minus z plus 1 equal to 0. Now verify that which point lies on the plane. Substitute root 2 1 4. Root 2 into root 2 2 plus 1 3 plus 1 and minus 4. So point A lies on the plane. That root 2 comma 1 comma 4 lies on root 2x plus y minus z plus 1 equal to 0. Okay. Also passes through the point. There ends the matter. You please try to similar questions. Keep watching my channel and enrich your knowledge. Thank you very much. Please subscribe my channel.